imagine, if you will, that you're stepping into a computing time machine.
Oh, I mean, I love a good time machine hypothetical.
Right. So we're dialing the clock all the way back. We're stepping completely out of the modern era of, sleek glass smartphones and all that invisible cloud computing stuff.
Yeah, leaving all the comfort behind.
Exactly. And we are landing right in the absolute middle of October 1984.
Wow, okay. Peak home computer wars.
Literally the boiling point. So you open the time machine door, and you're standing in the middle of this high street electronics shop. And the market is just, well, it's incredibly chaotic.
It was a mess. A glorious mess, but a mess.
Yeah, the shelves around you are just groaning under the weight of dozens of completely incompatible machines, all fighting for dominance.
Right, you've got the Sinclair ZX Spectrum, the Commodore 64, of course.
Yeah, the Acorn Electron, the VIC-20, all of them. And if you look closely at all of those machines, they share a very specific, undeniable aesthetic.
You do. They were all built to a very, very strict price point.
Right. They are all housed in this beige, gray, or maybe off-white plastic, and they often feature these rubbery, dead-feeling keys that kind of wobble when you press them.
Because cost-cutting was basically the central religion of the era. I mean, the whole goal was to convince parents to buy these things for their teenagers' bedrooms,
Exactly. Keep the price low. But then you look over into the corner of the shop, away from all those plastic toys, and one British company decided to just completely reject that entire philosophy.
They really went in the exact opposite direction.
They did. They released this premium, imposing, black-brushed aluminium beast of a machine. I mean, it looks like high-end stereo equipment.
It really does. It has that hi-fi look.
And it comes complete with what a reviewer at the time literally described as a sports car-style stripe running right along the top.
Yeah, the red stripe. And, that aesthetic departure is actually the perfect entry point for understanding what this company was trying to achieve.
Right, which brings us to the topic of our deep dive today. We were talking about the Memotech RS128.
A fascinating piece of hardware.
It really is. And our core mission today is to explore the anatomy of this incredibly ambitious machine. Because it was attempting to pull off this nearly impossible balancing act.
It was trying to bridge two entirely separate universes, really.
Yeah. On one side, it desperately wanted to be the ultimate premium home computer for the hobbyist, just packed to the brim with built-in programming tools and gorgeous graphics capabilities.
Right, but then on the other side, it was engineered to transform into a fully expandable professional CPM business system, one that could actually go toe-to-toe with the heavyweights in a corporate accounting office.
Which is just a wild proposition.
It is, and that tightrope walk is what makes the RS128 such a profound case study in product positioning and really technological ambition.
I agree completely.
I mean, we are looking at a company that basically refused to choose a single demographic. They looked at the hardcore assembly language hacker, the curious adult beginner, and the small business owner managing payroll, and decided they could build a single, sprawling, modular ecosystem to satisfy every single one of them.
Which, spoiler alert for you listening at home, is a very dangerous game to play. So we're going to tear this machine down to the studs today.
Let's do it.
We're going to look at the engineering behind that heavy metal exterior, the shockingly advanced development tools baked right into the hardware, and a very strange text language called Noddy.
Oh, Noddy is such a weird artifact.
It's so weird. And then finally, we'll look at the incredibly expensive, almost Frankenstein-like physical metamorphosis that was required to turn this living room computer into a true business workstation.
It's quite a journey.
Okay, let's unpack this, starting with the exterior. You mentioned the economic necessity of plastic for other companies. Memotech goes with heavy, black-brushed aluminium.
Yeah, a huge departure.
My immediate instinct is to look at that metal case, look at the literal red racing stripe painted on it, and just assume this is pure, unadulterated psychological marketing.
Like dressing for the job you want, not the job you have.
Exactly.
Yeah.
It feels like they're putting a three-piece suit on a home computer to scream, hey, take my price tag seriously. So was there actually any functional engineering purpose to wrapping a computer in heavy metal?
Well, I mean, the psychological aspect was undoubtedly a massive factor in their marketing strategy.
Well, obviously.
But the material choice was actually highly functional. It addressed two distinct engineering challenges of early 8-bit computing. The first being thermal management.
Heat.
Right, heat. Processors and memory chips of that era generated a surprising amount of heat. And plastic, as we know, acts as an insulator.
It just traps it all inside.
Exactly. It traps the heat inside the casing, which is why so many early computers required loud internal fans, or they just suffered from thermal throttling and random crashes after a few hours of use.
Nobody wants their essay to just vanish because the computer got too warm.
Right. But aluminium, conversely, is an excellent thermal conductor. The entire chassis of the RS128 essentially acted as a massive passive heat sink. It literally pulled heat away from the internal components and dissipated it into the room.
Which means it runs silently. You don't have a whining fan ruining the vibe in your living room while you're trying to work.
Precisely. And then the second major factor is electromagnetic interference, or EMI.
Oh, right. Because TVs back then were basically radiation cannons.
They really were. The 1980s living room was an incredibly noisy environment electronically. You had CRT televisions emitting massive amounts of radiation, poorly shielded power cables, and the computer itself generating radio frequencies.
Which could bleed out and ruin the television picture it was trying to display in the first place.
Yes, exactly. And a plastic case offers zero protection against that. An aluminium chassis acts as a Faraday cage. It keeps the computer's internal electrical noise contained, and it shields the sensitive logic chips on the motherboard from outside interference.
That's actually really smart engineering.
It was. The reviewer at Personal Computer World in 1984 picked up on this immediately, noting the solid construction wasn't just for show.
Okay, that makes a lot of sense. But if the case is the suit, the keyboard is the handshake, right?
Yeah.
And this is where I feel like Memotech was drawing a massive line in the sand regarding their target audience.
Oh, absolutely. The keyboard tells you exactly who they wanted to buy this.
Because if you use the ZX Spectrum, you were typing on what felt like dead flesh. Just these horrible, squishy rubber keys.
The dreaded dead flesh keyboard.
Yeah. And even the Commodore 64, which had a real keyboard, it still felt pretty clunky. But the RS-128 featured a 79-key professional board. That is a massive footprint for 1984.
It is. A 79-key layout fundamentally changes how a human interacts with the machine.
How so?
Well, a standard home computer of the time usually had around 40 to 50 keys. They heavily relied on the user holding down multiple shift and control keys to access basic programming commands or even just punctuation.
Right, doing finger gymnastics just to type a quote mark.
Exactly. By expanding to 79 keys, Memotech dedicated physical space to discrete functions.
You had the 57 standard QWERTY keys, which is expected, but then they added a dedicated numeric keypad sitting right off to the right side.
Which is huge for a specific type of user.
Yeah, because if you are a teenager playing Pac-Man, a numeric keypad is entirely useless to you. But if you are an accountant doing data entry or a scientist inputting variables, it's the most important part of the machine.
And that keypad also doubled as your cursor and editing controls, which was very modern.
Yeah. On top of that, they included a bank of 8 dedicated function keys. If you held Shift, that gave you 16 programmable functions. But there was one physical detail that just blows my mind for a machine that could be plugged into a family TV.
The home row markers.
Yes, they engineered deeper physical recesses onto the F and J keys.
What's fascinating here is that the inclusion of deeper recesses on the F and J home row keys is the ultimate tell for Memotech's true ambition. Those recesses are physical anchors for touch typists.
Right, because a kid pecking out a 10-line basic program with 2 index fingers does not care about home row anchors.
Not at all. But a professional secretary or a novelist typing 90 words a minute absolutely relies on them to orient their hands without looking down at the board.
It's such a tiny detail, but it speaks volumes.
It really does. The Personal Computer World Review explicitly praised this, noting the keys were nicely spaced with a very positive professional feel. It communicated to the user that this machine was designed for long, grueling sessions of serious text generation.
It is such a specific demographic marker. They even put 2 unmarked keys on either side of the spacebar, and if you press them both simultaneously, it triggered a hard reset of the computer.
A very clever way to avoid accidental resets during a busy typing session.
It's just a beautifully thought-out piece of industrial design. But here's the twist that really caught me off guard. With all this premium exterior design, they didn't actually build a brand new computer architecture for the RS-128, did they?
No, not entirely.
Underneath that sleek metal, it was essentially a recycling job.
Well, recycling might be a slightly harsh term, but it is true that the RS-128 was an iterative evolution rather than a ground-up revolution. The core architecture of the machine was actually their older, previously released model, the MTX 512.
Wait, really? So they basically took last year's model, maxed out the stats, and just gave it a new name.
In essence, yeah. Memotech took that existing motherboard and upgraded it internally by adding 2 specific plug-in expansion boards right at the factory.
Just slotted them in before shipping it up.
Exactly. They plugged in a 128 kilobyte RAM expansion board into the right-hand end of the main PCB, and they added a dedicated RS232 communications board.
Ah, which is the literal origin of the machine's name.
Yes, the RS stands for the RS232 communications board, and the 128 denotes the total kilobyte count of the expanded memory.
That's pretty clever, actually.
It was. The architecture was modular enough that if a consumer already owned the older, cheaper MTX 512, they could technically upgrade it into an RS128 by purchasing and installing those 2 exact boards themselves.
Okay, that actually speaks really well to their engineering foresight.
Yeah.
You know, building a motherboard that could scale up that significantly without having to buy a whole new computer.
It was a very consumer-friendly approach to upgrades, at least at that specific level.
And because they added that RS232 board, the back of this brushed aluminum briefcase was just absolutely loaded with connectivity. You had the 2 RS232 serial ports, which were essential for modems or high-end business peripherals.
Crucial for business.
You had a Centronics parallel printer port. You had outputs for both standard RF television and crisp composite monitors.
And they also included a dedicated hi-fi audio output jack.
Really leaning into that stereo equipment look.
Yeah, this is another nod to the premium adult user. Instead of forcing you to listen to computer beeps through a tiny, tiny television speaker, Memotech allowed you to route the computer's sound chip directly into your living room's stereo amplifier.
For a much richer auditory experience. That's awesome.
Yeah.
But they didn't entirely abandon the teenager either, right? The back also featured standard cassette tape connections.
Because it's 1984, and tapes are still the primary storage medium for the masses.
Right, and they had 2 standard joystick ports for gaming. So you could run a massive payroll spreadsheet at 5:0 p.m. and then plug in a joystick and fire up an arcade shooter at 6:0 p.m.
Work hard, play hard.
Exactly. It really seems like they covered every single base on the outside. But let's move beyond the exterior.
Let's get under the hood.
Yeah, you've brought this heavy metal machine home. You've plugged the external power brick into the wall. You hit the power switch. What actually happens? Because the real magic of the RS128 wasn't the aluminium. It was what was waiting for you the second the screen flickered to life.
The software environment was where it truly shined.
So let's talk about the Z80 and the built-in development tools.
When you unscrew those aluminum panels and look at the main circuit board, the brain of the operation is the Zilog Z80A microprocessor.
The legend.
The absolute legend. This chip was the workhorse, the undisputed king of the 8-bit era. It powered everything from the Pac-Man arcade cabinets to the early Game Boys. And in the RS128, it was clocked at 4 megahertz.
Now, to a modern listener, 4 megahertz sounds absurdly slow when our phones run at multiple gigahertz. But in the context of 1984, why does that 4 megahertz clock speed actually matter?
Well, clock speed dictates how many instructions the processor can execute per second. Many competing machines, like the Commodore 64, ran their processors at roughly 1 megahertz.
So a quarter of the speed.
Roughly, yes. The ZX Spectrum ran closer to 3.5 megahertz. So a solid 4 megahertz on the Z80 meant the machine could calculate game logic faster, sort databases quicker, and handle complex graphical math with less stuttering.
It was just a very robust speed for that specific architecture.
It was. And sitting alongside that processor was the 128K of user RAM we mentioned, 16K of dedicated video RAM for the graphics, and crucially, 24K of ROM on the main board.
That 24K of ROM is the entire secret weapon of this computer.
It really is.
For you listening who might not be deep into vintage computing architecture, we need to explain the difference between RAM and ROM here.
A very important distinction.
Right, because RAM is your short-term memory. It forgets everything the second you pull the plug. If you want to program in RAM, you have to load it from a tape or a disk every single time you turn the machine on.
Which takes time.
A lot of time. But ROM, read-only memory, is permanent. It is etched into the silicon. The software in ROM is instantly available. The exact millisecond the power switch clicks.
And this is where Memotech made a monumental decision regarding their target audience. When you switched the RS128 on, you weren't greeted with a flashy logo or a menu screen.
Right, no fancy graphics.
You saw a black screen, a flashing white cursor, and a simple message that said, "Ready." It looked incredibly Spartan. But hiding right behind that prompt, packed into that 24K of ROM, was an entire suite of professional software development tools.
That's like a sleeper car.
Exactly. You had MTX Basic, naturally, but you also had an assembler, a disassembler, and a machine code monitor, which was often referred to as a front panel.
Okay, I want to focus on the assembler for a moment because this fundamentally changes the quality of life for a programmer in 1984.
It was revolutionary for home coders.
If I am a hobbyist on a competing machine and I want to write fast, low-level machine code, what is my normal Friday night like? I assume it involves a lot of waiting.
Oh, it involved agonizing amounts of waiting and frustration, usually to write in assembly language, which is the human-readable version of the raw ones and zeros the processor understands. You had to purchase an assembler program on a cassette tape.
Okay, so I buy the tape, then what?
You would type a load command, press play on your tape recorder, and listen to electronic screeching for 10 minutes while the program loaded into RAM.
10 minutes just to start working.
Yes, and if there was a slight volume fluctuation on the tape, it would crash and you'd have to start over. Once the assembler finally loaded, then you would write your code.
And what happens if you make a mistake in your code?
This was the nightmare scenario. Assembly language gives you direct control over the hardware, which means if you make a single typo, if you put a value in the wrong memory address, your code won't just give you a friendly error message.
It doesn't just say syntax error.
No, it will instantly crash the entire computer. The screen freezes, the keyboard locks up. Your only option is to pull the power plug.
Oh, no.
And because RAM is volatile, when you pull that plug, your code is gone, and the assembler program you spent 10 minutes loading is also gone.
You have to start the entire agonizing 10-minute tape loading process from absolute scratch just to fix one missing semicolon.
It was psychological torture, truly.
But on the RS128, because the assembler is in ROM, it can never be erased. It can never be crashed out of existence.
Precisely. From the basic ready prompt, you simply type the command assemb. Instantly, in a fraction of a second, you are inside the assembler.
That's incredible.
You can write your code, test it, and if it crashes the machine, you just hit the reset button. The machine restarts instantly. You type assemb again, and you are right back to work.
It completely removed the friction of low-level programming.
It essentially turned the RS128 into a ready-made professional development kit out of the box.
That is amazing. But they went even deeper than that with a front panel machine code monitor. I really need you to explain this to me because it sounds like absolute black magic for a home computer.
The front panel was a tool for the most hardcore developers. In modern terms, it's basically a low-level debugger. It allowed the user to inspect any specific address in the computer's memory and edit the raw hexadecimal values directly.
Okay, so peeking and poking at the raw data.
Right. But its most powerful feature was allowing the programmer to follow the exact contents of the Z80's internal registers while a program was running.
Let's break down what a register is for the listener, because if RAM is, say, the giant pantry where all the ingredients for a recipe are stored, what is a register?
Good analogy. A register is the chef's cutting board. It is a tiny, ultra-fast piece of memory located directly inside the processor itself.
Right, so the processor can't just do math out in the pantry.
Exactly. The processor cannot perform math on data while it's sitting out in the RAM pantry. It has to fetch the data, place it on the register cutting board, chop it up or add it together, and then send the result back to the pantry.
So this front panel tool basically gave the programmer X-ray vision.
Yes.
You aren't just watching the program run on the screen, you are watching the chef's hands in real time. You can pause the execution, look at the cutting board, and say, the value here is a 4 when it should be a 12. That's why my game is crashing.
The PCW reviewer noted that this feature alone would have Z80 machine code freaks champing at the bit.
I bet.
It offered a level of granular visibility into the Silicon's thought process that was usually reserved for highly expensive corporate development mainframes, not something sitting on a dining room table.
Okay, but this brings up a massive conceptual clash for me.
How so?
Well, I look at this ROM, and I see beginner-friendly BASIC sitting literally next door to a hardcore machine code front panel that requires you to read hexadecimal processor registers. It feels completely schizophrenic.
It is a very wide spectrum of tools.
My best analogy for this is like buying a comfortable standard family sedan for your morning commute. You open the door, the seats are plush, the radio's nice, but welded directly to the dashboard with exposed wires running into the engine block is a professional mechanic's diagnostic computer.
That's a great visual.
Right. Why would a company put tools for the absolute most extreme 1% power users in the exact same ROM chip as the tools meant for children, Who are they actually trying to sell this to?
You have identified the central fatal flaw in Memotech's corporate philosophy right there.
Yep.
They were terrified of alienating anyone.
They wanted everyone's money.
They looked at the market and saw that the BBC Micro was capturing the educational sector, the Commodore was capturing the gamers, and the IBM PC was capturing business. Instead of picking one of those lanes and optimizing for it, they tried to pave over the entire highway.
Which is a very expensive way to build a road.
They believed that if they simply offered every conceivable tool from the absolute highest level beginner language to the lowest level hardware debugger, the RS128 would be the universal answer to computing.
And nowhere is that desperate desire to cater to everyone more apparent than in the most bizarre piece of software packed into that ROM. Let's talk about Noddy.
Oh, Noddy.
This is a language that feels like it dropped out of a parallel universe.
Noddy is a truly fascinating artifact of computing history. The reviewer noted that simply arriving at a flashing ready prompt was actually a shame because it completely obscured the unique tools waiting inside, and Noddy was chief among them.
Right, because you wouldn't even know it was there.
Memotech's official marketing pitched Noddy as doing for text what Logo does for graphics.
Okay, let's contextualize Logo for a second. Logo was that famous educational language where you commanded a little digital turtle to move around the screen, drawing lines behind it.
Right, forward 10, right 90.
Exactly. It abstracted the terrifying syntax of programming into physical logic. It taught kids geometry and logic loops without them realizing they were coding. So if Logo is an abstraction engine for drawing, what does an abstraction engine for pure text actually look like in 1984?
In practice, Noddy stripped away almost all the mathematical and variable-based complexity of traditional programming. It focused entirely on information flow, user input, and screen display.
Okay, so how did it work?
Well, instead of writing long, scrolling lines of code, a Noddy project was structurally organized into discrete units called pages.
Like a book or a magazine layout.
Very much like a stack of index cards, actually.
Yeah.
In Noddy, a page could be defined as one of two distinct things: a data page or a program page.
Look, the data page.
A data page was exactly what it sounds like. It was a blank canvas. You gave the page a title, and then you could freely type any text you wanted onto the screen exactly as you wanted it to appear. You could format a recipe, a restaurant menu, a business address, or a screen of instructions.
That sounds incredibly simple, almost like a very primitive version of PowerPoint or a digital slide deck. But how did you make those static data pages interactive? Where does the actual programming happen?
The interactive logic lived in the program pages, and this is where Noddy stands in stark contrast to everything else on the market.
Okay, tell me about the programming pages.
If we compare it to MTX Basic, Basic is incredibly versatile, but it is notorious for devolving into what programmers call spaghetti code. You have jug-o commands jumping wildly back and forth across hundreds of numbered lines, making it incredibly difficult for a beginner to read or debug.
Right, it gets messy fast.
And assembly language, as we discussed, is granular to the point of pedantry. Noddy, conversely, was highly structured and severely limited. It utilized a total vocabulary of only 11 commands.
Wait, really? 11 commands? You can't build a spreadsheet or an arcade game with 11 commands. It sounds insanely restrictive.
It was intentionally restrictive to enforce a specific type of logic. The commands were immediately readable to a layman. You had the display command, which simply took one of your data pages and pushed it to the television screen.
Nice.
You had the enter command, which paused the program and waited for the user to type something on the keyboard. You had the if command, which tested the user's input against a condition. And then you had branch and goto to move the logic to a different program page based on that input.
I have to admit, I have a deep, genuine enthusiasm for this weird little language.
It's very charming.
When you explain the structure, displaying a page, asking for input, and branching to a new page based on that input, it sounds exactly like an early engine for a choose-your-own-adventure novel. Yeah. Or, honestly, it sounds like a proto-version of Apple's HyperCard or modern interactive fiction tools like Trine, existing years before those concepts were popularized. You are completely abstracting the terrifying syntax of variables, loops, and memory management into pure logic flow.
It's pure branching logic.
You can literally read it aloud. Display the main menu data page, wait for enter. If they type 1, branch to the chicken recipe page. If they type 2, branch to the beef recipe page. It's brilliant for a non-technical person.
It really was an elegant solution for a specific problem, and you didn't even have to abandon your traditional programming to use it. Noddy was deeply integrated into the system.
Oh, it was.
Yeah, you could be writing a massive, complex MTX basic program, and if you suddenly needed to display a multi-page help menu for the user, you could call a Noddy routine directly from BASIC using the command PLOD.
Wait, the command to launch the program was literally PLOD, like a policeman walking the beat.
Yes, Memotech fully committed to the Enid Blyton branding there.
That is hilarious.
And to ensure the code didn't get confusing, every single Noddy command was prefixed with an asterisk. So if you were looking at a long listing of code, it was instantly visually obvious which lines were basic and which lines were Noddy.
So they play nice together.
Right. Once the Noddy routine finished displaying the help pages and getting the user's input, it returned control back to the main basic program via the return command.
It sounds like a fantastic tool for making kiosk software or digital encyclopedias. But what did the reviewer at Personal Computer World actually think of it? Was it dismissed as a gimmick, or did they recognize the utility?
Tony Hetherington, the reviewer, took it quite seriously, actually, though he admitted that because it was a completely proprietary and new language, the wider computing community knew very little about it.
Right, nobody had heard of it.
He assumed the majority of RS128 buyers would probably ignore Noddy and go straight into the familiar territory of BASIC. However, he strongly pushed back against that assumption. He didn't think Noddy was going to replace Logo for teaching young children, but he argued it was a vastly superior teaching aid for adults.
That makes total sense. An adult trying to learn logic for their small business doesn't want to draw geometric triangles with a turtle. They want to organize text and information.
Exactly. Hetherington pointed out that Noddy provided much more practical, real-world examples of programming logic. He highly recommended that even advanced users keep Noddy in mind specifically for creating screen display subroutines and instruction pages to incorporate into larger projects, simply because it handled text formatting so much more efficiently than basic print statements.
If we pull back and look at the bigger picture here, Noddy is the smoking gun of Memotech's identity crisis, isn't it?
If we connect this to the bigger picture, absolutely.
Because on one end of this 24K ROM chip, you have the machine code front panel for the elite Z80 hacker who wants to manipulate hexadecimal registers in real time. On the exact opposite end, sharing the exact same silicon, you have Noddy, a language designed for the terrified adult beginner who just wants to build a digital recipe book without learning what a variable is.
It is the ultimate manifestation of their desire to be the Swiss Army knife of computing. They were offering a tool for every conceivable skill level, fundamentally refusing to acknowledge that a product that tries to be everything to everyone often ends up perfectly satisfying no one.
Okay, so they have the low-level hackers covered, and they have the text processing adults covered. This is 1984. The home computer market is driven by an insatiable hunger for vibrant arcade-quality games. Nobody's dropping $399 on a machine just to read text on a screen.
The games sell the hardware.
Exactly. Let's look at the visual architecture. What were the graphics capabilities of this heavy metal box?
The visual heavy lifting was delegated to a very well-regarded video display controller chip from Texas Instruments, specifically the TMS991EA series.
Good chip.
Very good. This chip provided a maximum high-resolution display of 256 by 192 pixels, and it could display a palette of 16 distinct colors.
Now, a 256 by 192 resolution with 16 colors was fairly standard for the era. The ZX Spectrum had a similar resolution, but the RS128 had a massive ace up its sleeve that fundamentally changed how games and animations were programmed on the system. Hardware sprites.
Yes, up to 32 of them are roaming the screen simultaneously.
We really need to explain what a hardware sprite actually is, because it's a concept that has largely vanished from modern computing.
To understand the magic of hardware sprites, we really have to look at the alternative. If a computer doesn't have hardware sprites, drawing a character on the screen like a spaceship or a little man is entirely the responsibility of the main Z80 processor.
The processor has to do all the drawing.
Exactly. The processor has to calculate the math for every single pixel, draw the character, wait a fraction of a second, erase the character, calculate the new position, and draw it again. This requires an immense amount of processor time.
Which slows everything down.
Right. It slows down the game logic, it slows down the controls, and it often results in flickering graphics.
The processor is basically acting like an overworked animator, furiously drawing and erasing on a chalkboard.
Precisely. A hardware sprite offloads all that labor. A sprite is a self-contained graphical object that the Texas Instruments video chip manages independently of the main background picture.
So the Z80 gets to relax a bit.
Exactly. The Z80 processor doesn't have to draw anything. It simply sends a tiny message to the video chip saying, take sprite number 1, which looks like a spaceship, and move it to X coordinate 100 and Y coordinate 50. The video chip handles the actual rendering effortlessly.
That's a huge performance boost.
And on the RS128, these sprites were normally 8 by 8 pixels square, but the chip could dynamically scale them up to 16 by 16 or even chunky 32 by 32 pixel blocks.
And this leads to one of the most conceptually challenging paragraphs in the entire personal computer world review. The reviewer, trying to explain the visual architecture, described the RS128's display as a 35-layer conceptual sandwich.
The sandwich metaphor.
Yeah. When I first read that, my brain just short-circuited. I assumed they meant the computer had 35 distinct image buffers in memory, like a modern Photoshop file with 35 high-resolution layers. But that's physically impossible for a machine with only 16K of video RAM, right?
It is entirely physically impossible. The 35 claim description is not a literal map of memory buffers. It is a conceptual metaphor to explain visual priority and how the Texas Instruments chip composite assembles the final television picture on the fly 60 times a second.
Okay, the best analogy I can think of to clarify this for you listening is traditional old-school cell animation. Think about how Disney animated Snow White, or how Warner Bros. Did Looney Tunes in the 1950s.
Oh, that's a perfect comparison.
You start with a painted background on a heavy piece of paper. Then you lay a completely transparent sheet of plastic cell over that background. Painted on that plastic cell is Bugs Bunny. If you want a tree in front of him, you lay another clear plastic cell with a tree painted on it on top of that.
Exactly.
You stack these clear sheets up, and the camera takes a picture looking down through all of them. The 35 planes of the RS128 work exactly like that stack of clear plastic cells.
That is a flawless analogy. The planes simply dictate which pixel wins the fight to be seen by the human eye. At the very back of the stack, you have the external video or border plane. Laying on top of that is a solid backdrop plane.
The paper background.
Right. Above that is the pattern plane, which holds your static high-resolution graphics, like the maze in Pac-Man. And then, stacked on top of everything else, are the 32 individual sprite planes, one for each of the 32 hardware sprites.
And priority is governed by altitude. The top sheet of plastic always wins. If Sprite 1 on the top plane physically overlaps Sprite 2 on a lower plane, Sprite 1 obscures Sprite 2.
Simple as that.
And anywhere there isn't a painted pixel on those top clear sheets, the colors of the maze or the background naturally show through. But as cool as that is, it isn't even the most mind-bending part of this video chip.
The virtual coordinate plane.
Yes, the physical television screen you are staring at in your living room is 256 pixels wide by 192 pixels tall. But the virtual world those sprites exist in, the coordinate plane they travel across, is vastly larger than that.
This is where the mathematical architecture of the chip becomes truly impressive. The coordinate plane that governs the sprites is a massive grid measuring 8,192 pixels by 8,192 pixels.
Over 8,000 pixels.
It's massive!
The visible television screen is just a tiny, microscopic window looking into this massive, sprawling, unseen mathematical universe. How does a computer in 1984 even track a graphical object that is 5,000 pixels off-screen?
It does it purely through integer math. The video chip doesn't have to render or draw the sprite when it is outside the 256 by 192 visible window. It simply continues to calculate its x and y coordinates on that massive 8,192 grid.
That is wild.
This allowed programmers to create incredibly complex looping attack patterns for enemies in a space shooter. You could have a sprite fly off the left edge of the visible television screen, continue traveling smoothly through thousands of pixels of unseen virtual space, loop around, and re-emerge on the right side of the screen at a perfectly calculated, mathematically consistent time.
And normally, to achieve that kind of fluid off-screen tracking and hardware control, a programmer would have to write agonizing machine code. They would have to use poke commands to manually push hexadecimal values into the video chip's raw memory registers.
It was considered a dark art.
But Memotech, leaning into their philosophy of empowerment, completely abstracted all of this terrifying math into basic, simple English commands.
They exposed the full power of that Texas Instruments chip directly to the MTX basic language. A hobbyist didn't need to learn a single line of machine code to build an arcade game.
They just used BASIC.
Yep. You had the genpat command, which allowed you to quickly define the shape and pixel pattern of your sprites. You had the sprite command, where you simply declared the sprite's starting X and Y coordinates, its speed, and its color. And then you had MVSPR, which stood for move sprite. You simply told the sprite to take a step in a direction, and the hardware handled the rest.
The reviewers specifically highlighted a command called ADJSPR, right? Adjust sprite.
Yes, that was a great one.
This let you change a sprite's speed or size on the fly while the program was running without having to completely redefine the sprite from scratch. You could make a spaceship instantly grow to 4 times its size to simulate an explosion just by typing a single basic command.
Very powerful.
You could even command sprites to automatically follow invisible lines or geometric circles that you had plotted mathematically on the background plane. It gave teenagers the power to write games that looked like they were coded by professionals.
And Memotech applied this same philosophy of elegant abstraction to the text display as well. We discussed earlier how restrictive the standard 40-column text display could be. MTX Basic completely subverted those limitations by introducing the concept of virtual screens.
Wait, virtual screens?
The operating system took the physical text screen and logically divided it into 8 distinct addressable windows.
Virtual window management, built into the firmware in 1984, before Windows or the Mac OS had truly normalized the concept for the public.
Yes. The system itself utilized 5 of these virtual screens for its own housekeeping. For example, the code editor screen was assigned 4 lines of space. The code listing screen took up 19 lines. The system assigned these tasks to virtual screens labeled VS0, VS1, and so forth.
Okay, so the system uses 5.
But crucially, that left 3 completely unassigned virtual screens, VS2, VS3, and VS6, entirely free for the user to manipulate using the CRVS command.
So a user typing in BASIC could just conjure up a discrete text window anywhere on the television screen.
They could set these user-defined windows to any rectangular dimension they desired. They could place them anywhere on the screen, they could use them to mix text and graphics simultaneously, and they could even make them physically overlap one another, with the active window coming to the forefront.
It was an incredibly sophisticated way to manage information on a low-resolution display.
It was way ahead of its time.
We should also touch on the sound capabilities, because they didn't skimp there either. The audio was generated by another Texas Instruments chip, the SN76489A. The PCW review noted it provided 4 distinct channels, 3 for musical tones, and 1 dedicated to white noise for sound effects like explosions.
A very standard, but very capable sound setup.
You commanded it with a simple sound command, defining the channel, the pitch frequency, the volume, and the duration. But the real genius was how the memory handled it. They utilized a dedicated sound buffer, activated by the SBUF command.
Ah, yes, the sound buffer.
This meant you could fire off a complex 10-second musical jingle, and the computer would continue running the game logic and moving the sprites while the sound played independently in the background. It didn't freeze the machine to play a beep.
When you compile all of these features, the massive touch typist keyboard, the heat-dissipating aluminium chassis, the instant-on Z80 development tools, the brilliant simplicity of Noddy, the hardware sprites, the virtual windows, the buffered sound, you're looking at what is arguably the ultimate, perfectly engineered 8-bit home computer.
It's an incredible package.
If Memotech had stopped there, the RS128 would be remembered as a legendary triumph of the hobbyist era.
But they didn't stop there. Because remember, the mission of this deep dive, this machine refused to just be a home computer. It had a desperate, burning ambition to be a serious corporate business machine.
A fatal ambition, you might say.
And to cross that chasm, the RS128 had to undergo a massive, incredibly expensive physical metamorphosis. It had to mutate. Let's explore the arrival of the FDX and the shift to CP/M.
Everything we have discussed up to this point, the incredible ROM tools, the graphics, the keyboard, was entirely contained within the $399 base unit. It was a sophisticated piece of technology, but fundamentally it suffered from the terminal flaw of all home computers of that era.
Which was storage and display.
Exactly. It stored its data on audio cassette tapes, and it displayed its output on a blurry television set.
And that is a fatal bottleneck. If you are running a small accounting firm, you cannot wait 12 minutes for a payroll ledger to load off a screeching audio cassette, only to get a random tape loading error at the very last second because the volume knob on your tape deck was turned 1 millimeter too high.
Unacceptable for commerce.
It's just entirely unacceptable.
Precisely. To be viewed as a legitimate business tool, a computer in 1984 needed 2 things: instant reliable data retrieval via floppy disks, and an industry-standard operating system.
Right.
Before MS-DOS and Windows conquered the corporate world, the undisputed king of business computing was an operating system called CP/M. It was created by Gary Kildall, and it had a massive, mature library of professional software spreadsheets, word processors, databases that were trusted by corporations worldwide.
But CP/M is a disk operating system.
It is. It physically cannot run on a cassette-based machine. It expects to boot from and constantly read from a mechanical floppy disk drive. To run CP/M on the RS128, you had to purchase a massive external hardware expansion called the FDX.
And when we say massive, we're talking about a physical transformation that completely alters the geometry of your desk. Describe what happens to your dining room table when you buy this FDX unit.
The FDX, the floppy disk system, was a gargantuan enclosure constructed from the exact same premium black-brushed aluminium as the main computer.
Just a giant metal box.
The PCW reviewer specifically noted that it was large by any standards. It was designed to sit either directly behind or alongside the RS128 keyboard unit. The front of this monolith housed two 500-kilobyte, 5.25-inch floppy disk drives.
And it was noisy too, wasn't it?
Well, because of the heat generated by the disk motors and the internal power supplies, it required its own active cooling fan, which meant the silent running of the base unit was now replaced by the constant hum of business machinery.
But it wasn't just disk drives in that box, was it? The FDX actually hijacked the visual output of the computer.
It had to. A 40-column television display is fine for writing a quick basic loop, but if you are loading a massive financial spreadsheet in CP/M, the industry standard was an 80-column pin-sharp display.
You needed to see more numbers.
Exactly. Therefore, housed inside the FDX enclosure was a dedicated 80-column display board capable of outputting a high-resolution signal to either a monochrome business monitor or a premium 16-color RGB monitor.
So you unbox this metal monolith. You set it next to your keyboard.
Yeah.
How did these two machines actually talk to each other? How did the FDX integrate with the RS128?
A thick data ribbon cable ran out of the FDX and plugged directly into an expansion slot located on the bottom of the RS128 keyboard unit. This allowed the main Z80 processor to access the disk drives and the new 80-column video card.
Okay, simple enough.
But the most bizarre and fascinating aspect of this union was how the system handled electricity.
This is my absolute favorite hardware quirk of the entire Memotech ecosystem. It is so strange. Here's where it gets really interesting.
When you purchased the RS128 base unit, it came with a very attractive external power supply brick with a convenient on-off switch. But when you upgraded to the FDX, you literally threw that original power supply in the closet.
You just didn't use it anymore.
Right. A heavy power lead ran out of the back of the FDX monolith and plugged directly into the RS128. The massive power supply housed inside the floppy disk enclosure entirely took over the job of powering the main computer's motherboard.
It is a total Frankenstein setup.
Right.
The brain of the computer, the Z80 processor, and the RAM sitting in the keyboard unit is literally being kept alive by the power supply of its own peripheral disk drive.
It's wild engineering.
It really is. But I want to focus on the psychological shift this causes for the user. Imagine you are a hobbyist. You bought the RS128 because it looked cool. You've been sitting in front of your family television, happily typing away in Noddy, making hardware sprites bounce around the 8,192-pixel virtual void.
Having a great time.
Having a blast.
Yeah.
Then you decide you want to start a home business. You drop the cash on the FDX. You buy a dedicated heavy CRT RGB monitor because you need that 80-column text. You cable it all together. The fan spins up with a mechanical roar, and suddenly your fun little living room toy has vanished. It has been replaced by a heavy, imposing, sprawling corporate workstation.
It was a profound environmental and experiential shift. The reviewer at PCW explicitly observed that when fully assembled, the RS128, the FDX, and a monitor formed a neat business system which would be equally at home in the office or on the dining room table.
But the true revelation for the user was the speed, wasn't it?
Absolutely. The transition from agonizing cassette loading times to the near-instant gratification of dropping a floppy disk into a drive, hearing the mechanical clack of the read head, and seeing a program boot in seconds was revolutionary. The reviewer rightfully declared it a fully-fledged CP/M system.
And the software ecosystem that opened up was vast. Memotech knew they couldn't just sell you empty disk drives. They had to provide the software to justify the upgrade. What came bundled with this massive FDX monolith?
The bundle was highly targeted toward immediate business productivity. First, they included FDX Basic.
A new basic.
Well, this is a logical extension of the standard MTX Basic you were used to in ROM, but it added a suite of self-explanatory commands specifically for disk access, supporting both sequential and random access files that were fully compatible with the CP/M file structure.
So you could write to disks.
Right. But the real value was the productivity software. It included SuperCalc, which was a legendary industry-standard spreadsheet program that the PCW reviewer noted required absolutely no introduction to anyone in the business world.
Basically the Excel of its day.
Exactly. And for text generation, it came with a word processor called NewWord.
Now, NewWord was essentially a legally distinct clone or adaptation of WordStar, right? And
Right.
WordStar was the absolute, undisputed titan of word processing in the early 1980s.
Exactly. NewWord provided the full WordStar experience, but it was specifically configured at the factory to map perfectly to the RS128's massive 79-key keyboard, taking full advantage of those dedicated function keys.
So the hardware and software were really talking to each other.
They were. The reviewer felt the integration was highly successful, noting it formed a very pleasant professional word processing environment. Furthermore, they pointed out that outside of the bundled software, a massive catalog of CP/M titles was rapidly becoming available on Memotech formatted disks.
Covering everything.
Business tools, educational software, and even complex strategy games from established companies like Level 9, Ocean, and Lothlorien.
But let's play devil's advocate for a moment here. What if I am a hobbyist and I really want to write a novel using a professional word processor like NewWord, but there is absolutely no way I can afford to buy the giant, expensive FDX disk system? Did Memotech offer any sort of compromise to bridge that gap?
They did offer a compromise, and it perfectly encapsulates the agonizing friction of their everything-to-everyone philosophy. If you couldn't afford the disk drives, you could purchase the NewWord software on a plug-in ROM cartridge board for $75.
Okay, that sounds like a fantastic deal.
Yeah.
You plug a 75 cartridge into the side of the keyboard, and you instantly have a professional word processor in ROM. No loading required. What's the catch?
The catch is the storage medium. The ROM version of NewWord had to be stripped down, containing fewer features than the disk-based version to fit on the silicon. But the fatal flaw was that because you didn't own the FDX disk drives, you were forced to save your massive professional word processing documents back onto consumer audio cassettes.
Oh, that is brutal. Imagine typing a 20-page quarterly financial report or a chapter of a novel. You hit save, and then you have to sit there staring at the screen, listening to your tape deck screech for 5 straight minutes, praying the tape doesn't snag or corrupt the data.
The reviewer called this a reasonable compromise, but honestly,
Compared to the instant save of a floppy disk, it sounds like an absolute nightmare.
it highlights the central tragedy of the RS128's modular design. The base machine offered several affordable entry points, but the truly capable, frictionless professional experience continually demanded that you purchase more hardware.
It's just a constant upsell.
Exactly. For example, you could also buy the highly regarded Hisoft Pascal programming language on a ROM board for around £50. The reviewer ran benchmarks and found it to be a very fast performer. But again, you had to save your Pascal code to cassette. Furthermore, the RS128 only had internal space for 2 expansion boards. If you had the memory expansion and the RS232 board installed, you physically had to open the machine and swap a board out just to plug the Pascal ROM in. It was a constant series of compromises unless you bought the ultimate FDX system.
And speaking of buying the ultimate system, we need to talk about the numbers.
Yeah.
We need to look at the cold, hard financial reality of this metamorphosis, because this is where Memotech's dream crashes directly into a brick wall. Let's break down the escalating financial realities of the RS128 ecosystem.
To understand the ultimate fate of this machine, we really have to meticulously analyze the pricing structure because the financial ramp from the living room to the boardroom was shockingly steep.
Let's establish the baseline first.
Right. The RS128 computer itself, the beautiful aluminium chassis, the touch typist keyboard, the Z80 running at 4 MHz, the 128K of RAM, and that incredible ROM packed with BASIC, the assembler, and Noddy retailed for $399.
And we have to acknowledge that $399 is a very aggressive, very tempting entry point. If you were a consumer in 1984 cross-shopping against the BBC Micro Model B or the Sinclair QL or the Advance 86, the RS128 looks like an absolute steal.
It was a bargain for what it was.
You're getting premium brushed aluminium and 128K of RAM, which obliterated the BBC Micro's meager 32K for a highly competitive price. It draws you in.
It was a remarkably strong value proposition on paper. It convinced the buyer they were getting a premium foundation. But as we've established, to realize the true business dream, to run CPM and SuperCalc without the agony of cassettes, you had to buy the FDX expansion.
And what did that cost?
The retail price for the FDX disk system was £870.
I really want you listening to absorb that number. You buy a premium computer for $399, and to add standard floppy disk drives to it, you have to pay £870. The peripheral costs more than double the computer itself.
It radically changes the value equation. This meant that the true exact total cost of the baseline CPM system, the RS128 keyboard unit, paired with the FDX, was $1,269.
Okay, so you are in for $12,069 just to get standard 1984 business capability. But the system the Personal Computer World actually reviewed on their test bench went even further, didn't it? They were testing a highly advanced specification.
They were. The specific review unit supplied to Tony Hetherington included an additional bleeding-edge piece of hardware, a 256K silicon disk.
We have to pause and explain this because when a modern listener hears the phrase silicon disk, their brain immediately jumps to a modern solid-state drive, an SSD. But in 1984, the technology behind a silicon disk was something entirely different, wasn't it?
Completely different. A modern SSD utilizes non-volatile flash memory. It permanently retains your data even when you power down the computer. The silicon disk inside the RS128 was an expansion board packed with standard volatile RAM chips.
Just normal RAM.
Right. The CPM operating system was tricked into treating this massive block of RAM as if it were a third physical floppy disk drive.
So it's a RAM disk. What is the actual functional benefit of tricking the computer into thinking RAM is a disk drive?
The benefit is sheer blinding speed. Mechanical floppy drives are inherently slow. A physical read head has to move across a spinning magnetic platter, find the correct track, and read the data sequentially. This takes time.
You're waiting on a motor.
Exactly. A silicon disk has 0 moving parts. Applications, databases, and massive spreadsheets could be loaded onto the silicon disk and accessed at electronic speeds. The PCW reviewer specifically noted that this instant access could make the difference between a software package that is functionally useful but agonizingly time-consuming and an invaluable, frictionless piece of daily software.
But the catch, the terrifying catch, is volatility. Because it is just RAM, it requires a constant flow of electricity to maintain its memory state. If your house experiences a microsecond power blip, or if you accidentally bump that nice little power switch on the FDX, every single piece of data on that silicon disk is instantly wiped out of existence forever.
That is the inherent danger. To use it safely, a business user had to develop a rigorous routine of transferring their working files from the fast silicon disk back to a physical magnetic floppy disk before shutting the machine down for the night.
That sounds incredibly stressful.
Despite that risk, it was a highly desirable upgrade. The reviewer noted that the FDX architecture was so robust it could theoretically be expanded to support up to 4 mechanical floppy drives and up to 3 additional silicon disk boards, offering immense headroom for corporate users.
But all of that silicon comes at a price. What did that single 256K silicon disk board actually cost to add to the system?
That single volatile memory board added an extra 385 POS to the bill.
That is staggering. A 256K RAM expansion cost almost as much as the entire $389 base computer. So let's do the final math on the system sitting on the reviewer's desk. You have the 399 base machine, you have the 870-ton FDX disk drive, you have the 385 silicon disk.
And that totals up to?
The exact calculated total for the fully expanded system comes to 1,654 board.
That is the exact mathematical total. In the text of the article, the editor rounded this figure down to a competitive 1,600 pounds in the conclusion and casually mentioned 250 pounds near the beginning as a shorthand for the non-silicon disk setup.
They were throwing a lot of numbers around.
Yes. For the sake of our deep dive title today, the 1,500-pound figure is a useful editorial shorthand for the fully realized business dream. But the stark reality of the invoice was 1,654. It is important to reiterate that the silicon disk wasn't strictly required to run CPM. The 12,269 configuration was fully functional. But the 1,654 system represented the machine operating at its absolute maximum intended potential.
To truly help you listening grasp the gravity of these numbers, we need to provide a provisional purchasing power context. 1,654 is a lot of money in any era, but in 1984 it was astronomical. If we scaled these 1984 British pounds to today using an illustrative UK CPI inflation multiplier to bring us to current day.
I must interject with a vital non-negotiable caveat before we do the math.
Go for it.
We are using an inflation multiplier strictly to understand general economic purchasing power, how much of a person's monthly salary is required. We must absolutely not conflate inflation-adjusted prices with technological value. Inflation measures the cost of bread and housing. It does not measure gigahertz or megabytes. A 7,000-pound computer today is a literal supercomputer compared to the RS128. We are doing this calculation solely to understand the financial pain inflicted on the buyer's wallet in 1984.
That is a crucial distinction.
Mm-hmm.
We're measuring the depth of the financial sacrifice, not the processing power. So with that understood, the tempting $399 down base price scales to roughly $1,660 a day. That is the price of a very premium, high-end, modern laptop. Expensive, but entirely justifiable for a serious hobbyist. However, that 870-pound FTX floppy drive scales to roughly 3,900 pounds today.
Just for a disk drive.
And that fully expanded 1,654 system, that scales to nearly 6,900 pounds today.
It is a breathtaking amount of capital for a small business or a solo entrepreneur to justify, and they had to justify it in a market that was rapidly flooding with a vastly cheaper, dedicated business alternative.
I have a theory about how Memotech thought they could get away with this pricing structure, and it ties directly into the sunk cost fallacy. It operates exactly like the modern business model of cheap inkjet printers.
Oh, the razor and blades model.
Exactly. You walk into a store, you see a printer for $50, and you think, what a bargain. You bring it home, you print 20 pages, and the ink runs out. You go back to the store, and you realize the replacement ink cartridges cost $80. You are trapped. The $399 RS128 is the cheap printer. It is the bait.
It's the hook.
You buy it because the aluminium is gorgeous, the keyboard is flawless, you love programming hardware sprites in BASIC, and you love the simplicity of Noddy. You are emotionally and financially invested in the ecosystem. But a year later, you decide you need to run real accounting software. You realize that to unlock the business dream, you have to walk up this incredibly steep, punishing financial ramp. You're already in for 399 pounds, so you can't just throw it away. Maybe you buy the 75 pounds ROM cartridge and suffer with cassettes. But eventually, you succumb, and you drop the 870 pounds on the FTX. Memotech's strategy was relentless financial escalation.
It is a devastatingly apt analogy. Memotech engineered a truly phenomenal technological foundation, but they locked the full potential of that foundation behind a paywall that required the buyer to possess incredibly deep pockets and a blind willingness to commit entirely to Memotech's proprietary modular hardware ecosystem. And this structural flaw brings us directly to the resolution of our deep dive, the ultimate fate of the machine.
So we have all the pieces on the board. The Personal Computer World Review was published in October 1984, and the verdict is glowing. The reviewer, Tony Hetherington, stated on the record that the RS128 would be a very tempting prospect for anyone buying a home computer with a view to future expansion.
He really liked it.
He lavishly praised the aluminium construction, the touch typist keyboard, the Instant-on Z80 development tools, and declared the fully expanded FDX setup a powerful CPM disk system. He even went so far as to say it held more appeal than dedicated business machines like the Advance 86 because of its superior build quality and ease of use, explicitly noting the keyboard was perfectly suited for heavy business use.
The contemporary documentary evidence is undeniable. The technological press absolutely loved this machine. They saw Memotech's vision clearly, they respected the high-quality engineering, they loved the built-in software suite, and they were awed by the immense, almost limitless expansion potential of the FDX architecture.
But, well, we are sitting in a time machine. We have the sobering benefit of historical hindsight. And the retrospective reality of Memotech is incredibly grim. Despite the glowing reviews, despite the aluminium and the sprites and the brilliant keyboard, Memotech completely collapsed.
They entered receivership in 1985.
Barely a year after this review was printed in Personal Computer World. So we have to ask the ultimate question. What happened? Why did this beautifully engineered business dream fail so spectacularly?
The failure of the RS128 can be traced directly back to the central tension we discussed earlier. It occupied an incredibly dangerous, totally unviable middle ground. By attempting to be both a premium home computer for the enthusiast and a professional CPM system for the corporation, it failed to be the optimal choice for either. Crucially, it demanded that the consumer single-handedly finance the massive, expensive chasm between those two use cases.
Let's look at it from the consumer's perspective. If you're a parent or a teenager who just wants a computer to play games and maybe learn a little bit of BASIC, $399 is at the absolute bleeding upper edge of the home market budget. You could walk out of that high street shop with a Sinclair ZX Spectrum for vastly less money, and the Spectrum had a library of hundreds of games ready to play today.
Right, you buy the Spectrum.
Conversely, if you're a small business owner with real capital to spend, and you are ready to drop 1,600 pounds on a complete system, you aren't going to buy a piecemeal modular system from a home computer company. You're going to buy a dedicated all-in-one IBM PC clone or an advanced 86, which offered the rapidly emerging standard of IBM MS-DOS compatibility rather than the aging CP/M standard.
That market reality raises a vital, nuanced question that we must address. Did Memotech go bankrupt because of the RS128? It is absolutely essential that we do not draw a simplistic line of direct causation here. The RS128 alone did not sink Memotech.
It wasn't just one product.
No, the broader British microcomputer market in 1984 and 1985 was undergoing a massive, brutal contraction. It was intensely competitive, cutthroat, and moving at breakneck speed. Memotech was facing severe financial pressures, overstocked inventory, and sales difficulties across their entire product line, not just with this one specific model.
Right. Corporate bankruptcies are rarely the fault of a single SECU. It is usually a systemic failure of cash flow and market timing.
However, while the RS128 didn't pull the trigger alone, the strategy behind the RS128 was deeply symptomatic of the commercial awkwardness that destroyed the company. Their fundamental business thesis, building a modular ecosystem that required massive sequential customer investment just to complete a basic functional business system, was entirely mismatched with how consumers and corporations were actually purchasing hardware in 1984.
It is exactly like the staircase analogy. They built a beautiful, structurally perfect, brushed aluminum staircase leading all the way to the stars. But they demanded $1,000 from the user for every single step they took. And eventually, people simply refused to climb.
They looked elsewhere.
Consumers looked at machines like the Sinclair QL. Now, the QL had its own massive, legendary engineering problems, but it attempted to offer a complete all-in-one package for a single price. They looked at the rising tide of IBM compatibles that offered everything in one beige box. In the face of that competition, the RS128 was revealed to be exactly what it was: an elegant, beautifully machined, highly capable dead end.
It was a machine that possessed infinite technical versatility, but was burdened with a completely untenable commercial reality.
Which brings us to the end of our journey today. As we pull all of these disparate threads together, the hardware, the software, the economics, what is the ultimate takeaway from the story of the Memotech RS128?
The overarching lesson is that the RS128 was, by all contemporary engineering accounts, a fantastic computer. It was beautifully manufactured and possessed capabilities far beyond its peers. It offered a keyboard that true professionals could use all day. It completely bypassed the agonizing friction of cassette tape development by baking a robust suite of Z80 programming tools directly into ROM.
It really was a marvel.
It provided the quirky, structured, highly approachable logic of Noddy for beginners, while simultaneously offering hardware sprite manipulation for advanced game developers.
It was bursting with brilliant ideas, overlapping virtual text windows in BASIC, a chassis that acted as a silent, passive heatsink, a disk drive unit that took over the electrical load of the main processor to ensure stability. It was an engineer's playground. But its fatal flaw was the direct consequence of its ambition. It distributed all of those brilliant ideas across too many disparate, brutally expensive pieces of modular hardware.
That is the tragedy of the machine. Expansion potential, no matter how brilliantly engineered or seamlessly integrated, possesses zero commercial value if your target demographic lacks the financial resources to actually purchase the expansions. Memotech built a bridge from the enthusiast living room to the professional boardroom, but the tolls across that bridge was simply too expensive for the market to bear.
And that is exactly why this story matters to you, sitting here in the modern era. This is not just a nostalgic look back at a forgotten 8-bit computer with a cool red stripe. It is a textbook, foundational case study in product positioning and corporate hubris. It clearly demonstrates what happens when a company achieves absolute engineering brilliance, but entirely fails to align their pricing model and their ecosystem strategy with the brutal reality of the consumer's wallet. It is a lesson that the biggest tech companies in the world still struggle with today: the dangerous temptation of trying to make a single device be all things to all people, and asking the user to finance every step of that impossible journey.
The ambition behind the RS128 was magnificent. The technical execution of the hardware was genuinely impressive. But the underlying market logic was fatally flawed from the moment the blueprint was drawn.
So we want to leave you with a final, provocative thought to mull over as you go about your day. We've looked at the specs, we've analyzed the reviews, we've broken down the punishing economics. Put yourself in the shoes of a product manager at Memotech in late 1984. You are staring at that 870-pound price tag for the FDX floppy system. You know the market is aggressively shifting away from CP/M and moving toward IBM PC compatibility. How would you have pivoted the company's strategy to save them from bankruptcy?
That's the million-dollar question.
Would you have looked at those costs, abandoned the $399 home market entirely, and use that beautiful aluminium to build a dedicated, all-in-one 1,200-pound business machine from scratch to fight IBM directly? Or would you have gone the complete opposite direction? Would you have stripped the RS128 down to its bare essentials, removed the expensive RS232 ports, swapped the aluminium for cheap plastic, and fought a vicious price war purely on the budget home turf against Sinclair and Commodore?
It is the purest distillation of the innovator's dilemma. Permanently lock in a beautiful casing of brushed aluminium.
It truly is. Thank you so much for joining us for this deep dive into the archives. We've loved unpacking the premium price, the brilliant engineering, and the ultimate failure of the Memotech RS128 dream with you. Keep questioning the technology of the past, because those forgotten machines almost always explain the technological landscape of the present.
Indeed. It serves as a stark, permanent reminder that sheer engineering brilliance and feature checklists do not always guarantee commercial survival.
So the next time you are shopping for a sleek, premium, beautifully designed piece of modern technology that promises to seamlessly handle your gaming, your creative hobbies, and your professional business life, we'll step back into that imaginary time machine. Go back to October 1984. Look at the sea of cheap, successful plastic computers, and then look at that beautiful black-brushed aluminum beast with the sports car stripe. And ask yourself, is this new device a true revolution in computing, or is it just another very expensive, very beautiful dream? Take care, everyone.